Now in this problem, we have to calculate the efficiency of the turbine and efficiency of the turbine generator combined system. Now, when you look at the problem, you can see that the electrical energy output from the generator is given. And also, mechanical energy output from the turbine is given. So the generator takes this mechanical shaft energy from the turbine and it converts it into electrical energy. So we should be able to easily calculate the efficiency of the generator. When it comes to the turbine, we have the output of the turbine and we have to figure out the input energy into the turbine. And we know that is going to be the energy change of the fluid flow through the turbine. Specifically speaking, mechanical energy change of the fluid that flows through the turbine. And when it comes to mechanical energy of a fluid flow, we know that we have three parts: pressure energy change, kinetic energy change, and potential energy change. Now let's consider a fluid flow that flows from the top of a reservoir to the bottom of the reservoir and exits the reservoir at a given velocity. The amount of mechanical energy of this fluid flow is conserved. That is assuming there is no friction and there are no other losses. The amount of mechanical energy that flows on the top of the fluid flow should be there at the bottom of the fluid flow. If you consider the topmost position of this fluid flow compared to the bottommost position, the potential energy would be at the highest. However, because this highest position contains liquid that is almost at rest, it wouldn't have any kinetic energy. Similarly, at the bottom of this flow, you will have the minimum amount of potential energy. But since the fluid is flowing very fast, the kinetic energy would be at the highest. So what happens is, when the fluid is flowing through this fluid path, each component of the mechanical energy would have different amounts. However, the total mechanical energy would be conserved. When it comes to discussing a problem similar to this, there are few points that you have to understand. The surface of the water body or the reservoir is open to atmosphere, so it is at atmospheric pressure. Also, the fluid exiting the reservoir at the bottom of the reservoir is open to the atmosphere. That is also is under atmospheric pressure. When it comes to measuring height, we have to establish a reference line. Generally, it is easier to consider the bottommost position as the reference line. So in this case, we can consider the exit from the reservoir as the reference point. So when it comes to measuring potential energy, we have to consider the heights of each position compared to our reference line, and that will give us the potential energy. Now please pause the video and try to solve this problem using your knowledge on efficiency, combined efficiency of a system, and mechanical energy of a fluid flow. Now in this problem, we can consider point 1 as the top of the reservoir and point 2 as the exit of the fluid from the turbine. Now let's consider the fluid flow that flows from the top of the reservoir to the bottom of the reservoir and exiting the turbine. At the top of the reservoir, the pressure is at atmospheric pressure and velocity is at 0. So the pressure energy part and the kinetic energy part is going to be 0 for point 1. However, you have potential energy because we are considering that the bottom of the reservoir as the reference point. So we can calculate the potential energy on the top of the reservoir. Now the question does not specify what is the exit velocity of the water from the turbine. Now in this case, we have to assume that the turbine is operating at the highest efficiency. If the turbine is designed to be the most efficient design, exiting velocity of the water should be negligible because the turbine have extracted most of the available energy from the fluid flow. So let's consider that the exiting velocity of the fluid flow from the turbine is negligible. In that case, we can see that the mechanical energy at point 2 is equal to 0. So we can find the rate at which the mechanical energy of the fluid stream changes is equal to mass flow rate into the amount of mechanical energy that was there in point 1 minus mechanical energy at the point 2. So that is equal to the amount of potential energy that was available at the top of the reservoir. Now that we have established the amount of mechanical energy of the fluid, we can calculate the efficiency of the turbine generator system, and also we can calculate the efficiency of the turbine.